Today we are going to learn preparation of phenols. Phenols are also known as carbolic acid. First was isolated in early 19th century from coal tar. Nowadays, phenol is commercially produced synthetically. In the laboratory, phenol are prepared from the benzene derivatives by any of the following methods. First method is given from haloarenes. Chlorobenzene is fused with NaOH at 623 Kelvin temperature and 320 atmospheric pressure. Phenol is obtained by acidification of sodium phenoxide, so produced. Let's try to understand how this reaction takes place. Here chlorobenzene is given when it is fused with NaOH at high temperature 623 Kelvin and pressure is 300 atmospheric pressure. At this high temperature and pressure range, this chlorobenzene undergo nucleophilic substitution reaction. As a result of it, it forms sodium phenoxide. When this sodium phenoxide treated with acid, it gives phenol. So this is the phenol. So that's how chloride is substituted by hydroxide. Now come to the next method, from benzenesulphonic acid. Benzene is sulfonated with oleum and benzene sulfonic acid so formed is converted to sodium phenoxide on heating with molten sodium hydroxide. Acidification of sodium salt gives phenol. Here this is benzene when it is treated with oleum. Oleum is fuming sulfuric acid. It is fuming sulfuric acid. H2SO4. When benzene is treated with fuming sulfuric acid, it forms benzene sulfonic acid. This is the benzene sulfonic acid. So let's try to understand this reaction. First of all, draw the structure of benzene. This is benzene. So when it is treated with H2SO4, it forms benzene sulfonic acid. So this is the benzene, and here this is sulfur double bonded to oxygen. On the other side also it is double bonded to oxygen. On the fourth side it is bonded to OH. So this is benzene sulfonic acid. This is benzene sulfonic acid. When it is fused with NaOH. So NaOH is a base and this is benzene sulfonic acid. So it undergo neutralization reaction, and as a result of it, here you will get sodium benzene sulfonate. Benzene sulfonic acid give away H plus ion and NaOH give away OH negative ion. So as a result of it, you will get sodium benzene sulfonate. So here this is sulfur, it is double bonded to oxygen. On the other side also it is double bonded to oxygen, and here Na. O carries negative charge, Na carries positive charge. So this is sodium benzene sulfonate. This is sodium benzene sulfonate. When this sodium benzene sulfonate again fused with NaOH. When it is fused with NaOH, it gives sodium phenoxide. So here this is benzene, oxygen carries negative charge, and here this is Na positive. So this is sodium phenoxide. And sodium sulfite is formed. This is Na2SO3. So that's how SO3 group is removed with the sodium. So when this sodium phenoxide treated with HCl, it undergo neutralization reaction, and here you will get phenol. So this is benzene. It is bonded with OH. So this is phenol. And here byproduct will be NaCl. So that's how From benzene, you can prepare phenol. Now come to the third reaction. Third reaction is from diazonium salt. A diazonium salt is formed by treating an aromatic primary amine with nitrous acid, which is a mixture of NaNO2 and HCl at 273 to 278 Kelvin temperature. Diazonium salt are hydrolyzed to phenol by warming with water or by treating with dilute acid. Now let's try to understand this reaction. This nitrogen is bonded to one carbon. This is primary aromatic amine. The other name of this is aniline. When it is treated with NaNO2 and HCl, the combination of NaNO2 and HCl forms nitrous acid. So that's how nitrous acid is produced. When it reacts with aniline, it forms benzene diazonium salt. Diazo means two nitrogens, and this nitrogen carries positive charge. That's why Em is added after diazo. So this is benzene diazonium. To balance this positive charge, Cl negative ions are present there. So that's why the name of this molecule is benzene diazonium chloride. When it undergoes hydrolysis, it forms phenol. N2 is a good leaving group because it can leave the molecule in the form of N2 gas, and Cl is removed in the form of HCl. That's how phenols are produced by using diazonium salt. Now come to the next method. The fourth method is from cumene. Phenol is manufactured from the hydrocarbon cumene. Cumene is isopropyl benzene. It is oxidized in presence of air to cumene hydroperoxide. It is converted to phenol and acetone by treating it with dilute acid. Acetone, a byproduct of this reaction, is also obtained in a large quantity by this method. So let's examine the reaction. Here this is isopropyl benzene. This is the isopropyl group. Attached to benzene is known as cumene. When it undergoes oxidation, it forms cumene hydroperoxide. This is cumene hydroperoxide is formed. So after the hydrolysis, you will get acetone as a byproduct and phenol is produced. So by this reaction, we will get phenol and acetone as a byproduct, which is also a useful compound. That's why most of the worldwide production of phenol is formed cumene, because in this reaction, byproduct which is obtained can be very useful. Now let's solve these Intext question. Show how are the following alcohols prepared by the reaction of suitable Grignard reagent on methanol. First of all, draw the structure of given alcohol. This is CH3, single bond CH. Here there is a branch of methyl. It is bonded to CH2 and this is OH. We have to prepare this alcohol from methanol. Now draw the structure of methanol. Methanol is one carbon aldehyde. So here this is one carbon. It is bonded to oxygen. On both the sides hydrogen is there. So this is methanol. When it reacts with Grignard reagent is RMgX. So as we have learned before, Mg carries positive charge and R carries negative charge. So that's why R will get attached to the carbon and Mg will get attached to the oxygen, which on hydrolysis gives alcohol. So here we have R. Now you have to identify the R which can produce this alcohol. Here this is the alpha carbon. This alpha carbon is the same carbon of the aldehyde. So here now we have identified which is the alpha carbon. Now you have to identify the R group. So this will be the R group. So now you can identify the R group. So the actual Grignard reagent will be, so this will be CH3 single bond CH Here it is bonded to CH3, and here this is Mg, and here we can take it as Br. So this is the Grignard reagent which can react with methanol to produce this alcohol. So this was the first reaction. Now come to the second reaction. Now again, first of all, draw the structure of alcohol. So this is the alcohol. Here this is cyclohexane. This is cyclohexane. It is bonded to CH2 and OH. So again, this is primary alcohol. And you know, primary alcohol can be prepared from methanol only. So this is again, draw the structure of methanol. C double bond OH. This is methanol. Now you have to identify the R group from which this alcohol can be prepared. And you know, the alpha carbon in this alcohol is the same carbon of methanol. So now you know the carbon of methanol is this. So identify the alkyl group. So obviously this will be the alkyl group. So now you can draw the structure of Grignard reagent. So this is cyclohexane. It is bonded to Mg, and here this is Br. So this is cyclohexyl magnesium bromide. This will be the Grignard reagent which on reaction with methanol can produce this alcohol. Now come to the next question. Write structures of the product of the following reactions. First question is given propene, and the reagent is given H2O in presence of H plus ion. Means there is hydrolysis or the addition of water takes place. The addition of water takes place according to Markovnikov rule. Means negative part of the reagent goes to the carbon which is bonded to less number of hydrogen. In water, negative part is OH negative ion. So it will get attached to the second carbon as it is bonded to just one hydrogen. And H plus will get attached to the first carbon. Now let's draw the structure of this molecule. So here I am going to draw the structure of product of first reaction. So here this is CH3 single bond CH single bond CH2. Here OH will get attached to the second carbon and H will get attached to the first carbon. So this is the structure of product of first reaction. Now come to the second reaction. In this second reaction, there is one ketone functional group and there is another ester functional group. And reagent is given NaBH4. NaBH4 is a reducing agent. It reduces ketone or aldehyde only, but it doesn't reduce ester functional group. Now let's draw the product. So this is cyclohexane. As NaBH4 doesn't affect the ester functional group. So here I am going to draw ester functional group as it is. So here this is CH2 single bond C double bond O O CH3. So this structure remains as it is. But NaBH4 reduces ketone. So when it reduces ketone to alcohol. So here you will get alcohol. So this is the structure of product of second reaction. Now come to the third reaction. In third reaction, there is aldehyde functional group is given and reagent is given NaBH4. This is a reducing agent. It reduces aldehyde to alcohol. So now draw the structure of the product of this reaction. So here this is CH3 single bond CH2 single bond CH single bond CH3. Here CH2 and now this is OH. So aldehyde functional group reduces to primary alcohol, while in the above reaction ketone functional group reduces to secondary alcohol. In the next video we will discuss of alcohol, phenol and ether, we are going to discuss physical properties.